All right, it's 11:50. Let's get started. Welcome to the maintainer track session for SPIRE. Thanks for making it out over here. I'm excited to talk about scaling SPIRE for performance and availability. I'm Julian. For those of you who don't know me, I'm a software engineer at Uber. I work on our identity access management team. I've been there for a number of years, working on building security infrastructure. On SPIRE, I'm a maintainer. I've been working on the project for about a year now. And I'm excited to talk about SPIRE and sort of how it's changed over time, what's important to the project, and how you can use that to build a zero-trust system. I thought I might begin with a discussion of trust, what that word means. The word fidelity in English comes from the Latin root fides, the Roman goddess of truth and honesty. And to trust someone in ancient Roman times was to say a prayer to the goddess Fides, to bless you with good faith and to watch over your trust. Now, this hasn't really stood the test of time, and today when we think about trust, we need a better definition. One that I quite like goes like this: trust is meant to convey an expectation of behavior. However, predictable behavior does not necessarily constitute behavior that's worthy of trust. For example, we expect a bank will behave like a bank, and we expect a thief will behave like a thief. Trust as expectation of behavior. Look at a practical example. Imagine that you and I were developing a service to deliver fresh produce to people, right? And so we would start with a front-end service that serves orders. And so we have Alice come, and she wants to take a look at some of her prior orders. Well, we could trust that Alice would only look at her data. We would have this expectation. But as we know, that's not a very safe expectation. We can't really trust Alice in this regard. So what do? We set up an identity provider to provide identity to Alice, some kind of cryptographic token, right? We set up a policy engine that defines what Alice can actually access. Alice can look at her data. She can't look at Bob's data. And so we've taken this expectation of behavior, and we've turned it into an enforcement of behavior. This is what it means to be zero trust, to be trustless, to remove this expectation of behavior. But we haven't removed trust completely. We've sort of just displaced it. We've taken the trust that we had in Alice and we've moved it to these components, the identity provider and the policy engine. But why do we trust those components? Where does that trust come from? Well, we had a developer set up the identity provider, we had a developer set up the policy engine, and the front end that glues these pieces together, right? Takes that identity, does authentication, takes that policy, and does authorization. So ultimately, the trust is coming from our organization, and you start to look at this, and this whole idea of trustless is kind of just an exercise in us learning to trust ourselves. But that's not the full story, right? Because trust has to come from somewhere. Right? And if we talked about earlier trust as an expectation of behavior, where does the expectation come from us as developers? And who sets that expectation? So when Alice or Bob, good old Bob, when they give us their data, when they set up an order with us, they're handing us their data and they're saying, protect this, secure my data, keep it safe. That's the expectation on us as developers. That's where the trust comes from. So we talk a lot about building zero trust networks, and we think that we're removing trust from the equation, but we're not. We're really building trust, okay? And so how do we get there? I want to talk about SPIFFE. SPIFFE is the Secure Production Identity Framework for everyone, and it's a specification that talks about workload identity. When we think about workloads, we're not talking about Alice and this front end. We're talking beyond the front end to this myriad of back-end services and how those communicate with each other. We want to secure that. Workload identity, it can be an X.509 certificate, it can be a JSON web token. For the purpose of this talk, I'm really just going to be talking about X.509, but they're sort of interchangeable in some sense. SPIFFE introduces these trusted components, the idea of a trust domain and a trusted authority at the root of that domain. And if you have workloads that are kind of loosely coupled inside this trust domain in organization A, and they want to talk with workloads in organization B, SPIFFE introduces this concept of federation to solve this problem that's been traditionally and historically very hard to solve. So a specification is nice, and implementation is nicer. That's where SPIRE comes into play. SPIRE is the SPIFFE runtime environment. First and foremost, what SPIRE is trying to do is solve this problem of bootstrap of trust. We saw in the earlier slide, trust comes from your organization, and you want to allow that to permeate into all of the components in your system. And so what SPIRE does is it allows that trust to permeate into your infrastructure. It needs to be portable, it needs to be cloud native, it needs to run on the public cloud, private cloud, bring your own hardware, anything. And we'll talk about what that looks like in a minute. It needs to be reliable, performant, observable. Identity and authentication, to me, needs to be built into the very foundation of your infrastructure. It's a core component like routing or persistent storage. And because of that, it needs to be really, really available. And when something goes wrong, we need to know about it. That's the essence of observability. We need to have the tools to fix those problems and recover effectively. Lastly, but most importantly, this thing needs to be secure, but not at the expense of usability. Developers so often want to do the right thing when it comes to security, and they don't know how. We should make that easy for them. So what I'm going to talk about today is a little bit of a high-level architecture of SPIRE, in case you're unfamiliar. The essence of short-lived credentials, which sort of form the base level of security for all of SPIRE. And then the various components, the agent, the server, and what registrations are all about. So for the purposes of this diagram, we can assume we have a multi-tenant system. We have a host, let's call it host X, with workloads A, B, and C. And so these workloads are heterogeneous. They're oftentimes unrelated. And the way that that these workloads interact with SPIRE is through an agent that lives on this host. And so you can imagine we'd have many hosts, host X, host Y, with a SPIRE agent located on each one of those hosts. And so the agent kind of acts as this data plane of the ecosystem, and it's forwarding policy information from the control plane, which is the SPIRE server. So ultimately, SPIRE Server is the root of trust in our system, and it's what allows delegation of trust into these agents. So SPIRE needs to store some policy information. It does that in a database. It needs to get policy information, and it does that through this component called a registrant. And that thing writes this policy information. And if you're not familiar, as you can see, workload A, we want to run on host X, but we don't want workload A to run on host Y. We need this policy, this thing that tells us exactly where a workload can run, because you can imagine if you have a secure group of hosts and you want to run secure workloads on that host, you need to be very specific about what should run where. And so this component, this registrant, is very coupled to your scheduler. If you have Kubernetes API server causing these workloads to come up, you need a direct integration there. And so that's why this registrant is a bit more, it's not a core really component of SPIRE because it's so coupled to the scheduler. Okay, so before I dig into these components a little bit, it's important to get a little bit of background on short-lived credentials that we use in SPIRE. And the big question everyone has is, why do you use short-lived credentials? Why don't you have a good revocation strategy? And spoiler alert, revocation is a very hard problem. There's a little bit of background on revocation strategies that have been used historically. There's this thing called a CRL, Certificate Revocation List. I receive a certificate and I want to know, is it valid? I consult with my CRL. This has some problems. The list doesn't really scale that well. There's problems with stale data, implementation difficulty of this thing. So there are some improvements, the online certificate status protocol. Instead of consulting with a list, I actually talk to a service, the OCSP responder. And I say, hey, is this X.509 certificate still good? This has a lot of the same problems. What do you do if that server's down? The implementations outside of browser software, the implementations are actually not that great. And so when we're thinking about using revocation in backend services, we don't have those same implementations from browsers. We have X.509 implementations in every language under the sun. And we need to think about that. That's why there's a third method of revocation that is sort of implicit revocation. Every certificate has a finite lifetime, a beginning date and an end date. When you pass that end date, the certificate expires. And what's really nice about this approach is when I receive an X.509 certificate, all I need really, I don't need a list or a service. The only thing I really need is a somewhat accurate clock. That's a powerful construct. But with the old methods of revocation, you might have these certificates that last years or months. And we need to rethink that if we want to be able to revoke quickly. And this is the essence of what it means to have short-lived credentials. These are credentials that only, instead of years or months, it's weeks, days, hours. Okay? And because they're turning over so quickly, we have this implicit revocation that's always happening. And so further, if you look at X.509 implementations across the board, this is not hard to get right. You're just checking, against a specific point in time. And so revocation becomes really, really reliable. But one of the problems is that rotation's still hard. So if you've ever used a server that implements TLS, you've seen configuration that looks like this. You have to provide a certificate and a key from a file. And when you have long-lived certificates, this is kind of fine, right? Once a year you go in and you update this file. It's not the greatest solution, but you don't have to do it that often, so why do you care about automating it? When you have short-lived credentials, you actually have to address rotation as a first-class concern. And actually what that does is it makes your rotation a lot more reliable. So how does rotation actually happen? So one of the parts of the SPIFFE standard is this thing called the SPIFFE Workload API. Instead of reading your credentials from a file, you make a gRPC call to a local agent. And that agent gives you credentials. And it uses a push model to continually update you every time that credential is rotated. And so this is part of what I'm talking about in terms of solving rotation as a first-class citizen. But a file read is so reliable, right? I mean, if the file's there, you get it. And we want this API to be just as reliable as a file read. So how do we achieve that? SPIRE Agent does this optimistic credential fetching. We talked earlier about how workloads need to be, in a way, assigned to certain hosts. And so SPIRE Server knows this policy. It knows every workload that could conceivably run on a host. And so the agent does this optimistic fetching, and by the time the workload starts on that host, it already has that thing cached locally. And so the workload hits this workload API, and the response is very fast. That's one of the benefits of this model of using a control plane and then a data plane that forwards a lot of this information, is you have this agent that can provide really, really fast and snappy responses. Another cool consequence of this is that you've actually decoupled the traffic between the workload and the agent and the server. So you can scale them independently, right? So you could have 100 calls from workloads to the agent, and then it doesn't at all impact the agent's upstream calls to the server. The request cycles are disjoint. And so as the number of workloads on a single host scales up, the server doesn't feel that load at all. This is really important for capacity planning as you start to scale up the number of workloads in your fleet. So doing this kind of caching, obviously you run into the age-old problem of consistency versus availability. When the agent can no longer contact the server, what do? Do you serve potentially stale data, or do you sacrifice being available? Again, we talked about this. We want to be very, very available. We want snappy responses. We have to decide to serve stale data. And because the nature of these X.509s, they're not rotating super often, so this is actually not very problematic unless the length of unavailability gets to such a point that your certificates expire. And so we'll talk about some strategies that we use to address that one. So on the server side, the server's providing agent authentication. We call this, in SPIRE parlance, this is node attestation. What this does for us is a bit of platform translation. So we talked earlier about needing to be platform agnostic, but the way you get there is by taking some platform-specific data, like an AWS instance identity token, or GCP instance identity token, or document, however it may be. Or if you have if you're running your own hardware and you have TPMs, trusted platform modules, you can use an endorsement certificate to translate into this very SPIRE-specific document, which is an X.509. And so we do this platform translation, and then the rest of SPIRE is totally agnostic to this platform. And this system is actually fairly pluggable. So when we were talking earlier about being portable, this is what gives us that portability, is taking this very platform-specific thing, converting it into something that's platform agnostic so that the rest of the system can run anywhere. So the main purpose of the server then is to issue these certificates to agents and workloads. One of the things to note is that as the number of agents and workloads scales up, obviously the amount of work that the servers are doing scales up as well. Signing operations do tend to get pretty heavy, but because this is CPU-intensive work, it's actually fairly trivial to parallelize. But more than that, there's another knob that we can tune. which is the certificate's lifetime, right? If a certificate only lives for a couple of minutes, the server is doing a bunch of work, right? It's constantly signing. And actually, as you begin to elongate that certificate lifetime, the amount of work that the server has to do sort of is tuned down a bit. So there's some cool knobs that we can turn there as users to kind of address that scaling problem. And beyond that, the server is managing this agent and workload policy, which workloads can run on which host. And the way that happens is through this process called registration. So backing up a bit, we talked earlier about how in Kubernetes, you have a scheduler cause a workload to come up, to boot, right? And so somehow SPIRE needs to be made aware of this placement decision. And so you need some kind of integration to allow this to happen. So we have this thing in the open source called the Kubernetes registrar that actually does this kind of integration. So we get a really tight integration with Kubernetes out of the box. But one of the problems here is, as you might notice, is in order for a workload to get its identity, it first needs to be registered with SPIRE. And this process can be kind of racy in terms of, is the workload coming up before the registration actually propagates through the system? We got to be aware of that thing. But not only that, the registrant is now a bottleneck for workload boot. That's a little bit of a problem from a reliability perspective, because now you have this extra component that needs to always be up in order for workloads to launch. So I want to talk a little bit about the thought process from a user's perspective of how you scale these registrations and avoid bottlenecks. A lot of what we've been talking about so far has been this idea of per host registrations. You have host X, and you want to run workload A, B, and C. That means when you launch workload A, you need to wait for that registration to propagate through your system. And beyond that, registrations are going to scale with the number of workload instances that you have. So if you have a kind of a disaster event where you need to reboot all of your workloads, you might run into a bottleneck here. And so this idea of per cluster registrations has sort of come about, which is that you register a workload against an alias of clusters. And then you only need to do one registration. This is really nice because once that cluster registration happens, you're not really blocked on this registrant being up. So it gives you kind of a two-pronged benefit. The main kind of difference between these two approaches in terms of security is really about limiting blast radius. If you only have workloads that are allowed to run on one host and that host is compromised, it's just the credentials on that host being compromised. But if you have many workloads running on a little bit of a larger cluster and one of those hosts is compromised, kind of in a way all of that entire cluster is compromised. So you really got to think about, what do you need from a business perspective? Is it okay? What's your threat model? If it's okay to think about these concerns, maybe in some cases you really do need that really tightness of policy, and sometimes maybe you don't. And so this is a really important knob that SPIRE allows its users to tune, because it's an important decision, and we can't necessarily be opinionated about how people do registrations. One thing I alluded to earlier was this idea of a certificate's TTL, time to live. It's their lifetime, the distance between the beginning and end time on the certificate. So one thing to note is that a low TTL means that you're revoking very quickly. You can imagine if you have a certificate with a 1 hour time to live and you accidentally log that as part of your logging infrastructure, it's kind of okay in a way, because within an hour, that certificate's no longer useful. But if your TTL on your certificate is a day and you accidentally log it, now you have to wait a full day while that certificate is potentially out there being used. And so a lower TTL means these things are constantly turning over and constantly being revoked, and it, in a way, reduces the risk of compromise. But, there's a but. An hour TTL means you have a 1 hour maximum time to recovery. If your control plane, if your SPIRE server goes down and it can no longer rotate these certificates, a clock starts ticking. And you have about an hour to fix that outage before kind of the whole system, in a way, breaks, and you have to re-bootstrap all of your trust. It's not a good place to be in. So we sort of have to balance this. If you have 24 hours to fix an outage, maybe that's a little bit more reasonable, but you have this security trade-off. So This isn't something that necessarily SPIRE can make the decision for the users. Again, it's a business decision. You have to understand what your threat model is and make a security decision. So a couple of takeaways here, because I do want to leave a good amount of time for questions. Caching is kind of the secret sauce of distributed systems, but you got to use it tastefully. You can't overdo it. Think horizontally. I think we're starting to see some users in the community, as they've started to scale up these things, we're starting to see some of the pain points of having these like multi-thousand node deployments in terms of how the server reacts to that kind of load. Some trade-offs, as we talked about, the TTL on certificates and the registration policy, how coarse we want that to be, should be tunable, right? These important decisions that, as a project, we can't necessarily make that decision for our users. You should leave those important decisions to the users, within reason. And finally, if you're interested in doing this kind of thing, come set up a POC. Join us on Slack. I'm always on Slack, super available, so happy to answer any questions. I'd be remiss if I also didn't mention that my team at Uber is hiring, so if you're interested in working on this stuff, come and talk to me. And thank you very much. So we got about 10 minutes for questions. I don't think that I have an extra microphone, but I can do my best to kind of run that around if anyone's got questions.
Hi, thanks for presentation. Quick question, are you guys considering using OCSP or OCSP step lane for revocation?
Yeah, so this is one of the things that I alluded to a little bit earlier on, is that OCSP, while it is used actually pretty prevalently in web browsers, the implementations on the backend server side are actually kind of fuzzy at best. It's hard to get right, and so a lot of implementations don't do it correctly. And the other problem is that when the OCSP responder is down, a lot of these implementations fail open, and they say, "Oh, couldn't get the thing. I guess certificate looks okay to me." And a lot of times that's the exact time that you need that, And so yeah, I think it was probably considered in the early days in the SPIFFE spec, but ultimately the sort of implicit revocation of short-lived certificates is the easiest to get right.
Yeah, but OCSP is tackling kind of solving this problem with where your CA OCSP server is not available.
Yeah, so the response here was that OCSP stapling, which instead of talking to an OCSP responder in line with your validation, you actually have your server who's presenting the certificate talk to the OCSP server and grab a signed response from that OCSP responder and then send it in line with the certificate. This has a couple other problems in the implementation. What do you do if that stapled response isn't there? Again, a lot of times they fail open. Sometimes it's not even implemented at all correctly in certain languages. And again, on the server side, you have to decide what to do if you can't get a signed OCSP response to staple. So there's a lot of failure modes there, and it's just this idea of adding that extra component into your trust model necessarily complicates the reliability story. Down in front here.
Hi. I was reading the installation instructions this morning and saw you mentioned the example of getting in AWS, say, the identity document from the metadata server. I hope you can maybe explain the threat model more. Does it matter if any other, say, pod or program running on that machine could also access the identity document? Does it matter who?
That's a great question. So the thing about AWS identity documents, and same with GCP, is that you retrieve that document by essentially doing a curl, an HTTP request to the local system in the cloud. And so potentially anything with access to the host network can retrieve this instance identity document that you're trading in for this very trusted credential. And so the model with SPIRE is a trust on first use for the agent. And so we assume that the agents are kind of the first thing coming up in your system. We only allow them to attest once. And so, I don't know, Evan, is there anything else you want to mention on this?
Yeah. Trust on first use is kind of like the primary mitigation for the concern you're talking about. I think the flip side is of course, it's a race, and of course, it can be lost. And in that event, because it's trust on first use, the legitimate agent will fail to come up, and you can page on that kind of a thing. So at the very least, it's certainly detectable. That's about as far as we can go from like the SPIRE implementation and mitigating that kind of a problem. There are of course other mitigations you can put in place as a user, like IP tables rules and things like this that can like limit access to those. But like from the project's perspective, we can't really expect that all users will do that, and so we take as many steps as possible to kind of mitigate this replay issue.
Does that survive reboot or the agent crashing?
So the question was, does it survive reboot? It can. The agent can be configured to persist. Like the result of that whole process of validating this instance identity document is an X.509 identity issued to the agent. And so the agent can be configured to persist that key and that certificate in RAM or on disk or against a TPM or something like this if need be. So it can survive reboot if configured appropriately.
Thanks, Evan.
Yeah, this is maybe a poll to you, but also the rest of the audience. In the wild, what's the kind of bare minimum that you've seen for that certificate expiry time? If you're really interested in keeping that down to a tight loop, you've got you've got a network you don't trust at all, and you want to keep that as small as possible. What's the smallest realistic window you've seen work?
Cool. So I think SPIRE, the default TTL on these certificates is an hour, if I'm not mistaken. We've seen people in the community using weeks. Personally, I would think something like in the realm of hours, inside of a day is a pretty decent policy. But it's a bit up to someone like your compliance team who's saying like, hey, we need to be able to revoke a certificate within X hours, right? And so that becomes a little bit of the upper bound on what you can tolerate. Yeah, so the question was, is it reasonable to expect 10 minutes? I think, do you know if people are using?
I don't know if anyone's going that low, but certainly there are implications that Tyler alluded to. For example, like that becomes like the minimum time that you can withstand an agent being down, for example. If it can't get that rotation, then it has to figure out how to like re-bootstrap trust into the system. SPIRE itself, like we have integration tests that run with like really low TTLs. You were talking like 15 seconds or 10 seconds, and that like SPIRE can handle that low of a TTL, but yeah, your room for failure, your tolerance for downtime gets really low at that point. So yeah, I think you want to go with as high as a TTL is reasonable in terms of like downtime tolerance, but as low as you can go in terms of like revocation, mitigation. So.
Cool. I'm going to go back here. We'll come back.
Quick question on the auto-scaling, descaling. So you mentioned about the workload. That should be a policy in SPIRE to define which workload deployed and what. If you have to auto-scale, descale all the time, how do you guys handle it? Because
Okay, so the question primarily is around how do you deal with auto-scaling and downscaling? Let me think about that a little. Have you had any experience with people doing auto-scaling? Okay. Yeah, so I'm guessing using some kind of like a node selector pattern here where you're registering against like a cluster or a group of hosts. And so as those hosts are sort of auto-scaled to come up, you actually have this registration against that group of hosts. So as long as the host is coming up inside this group that you've already created a registration for, you actually don't really need any kind of interaction with the SPIRE from a registration perspective, because the SPIRE agent comes up on that server, it kind of queries the SPIRE server, says, hey, what workloads do I need to know about, and has those identities available. Great question.
Not so much a conceptual question as implementation, but I saw also that workload is intended to communicate with the agents over domain sockets, mounting a host path. it's common to have pod security policies that won't allow mounting of host paths. So do you recommend whitelisting that path? Or what, is there an alternate choice for the workload talking to the agent?
That's a good question.
I'll answer that. Yeah, the host path, we've heard this a little bit now, and the host path is kind of the route that most people are taking. There's not really a good alternative at the moment. We've discussed the possibility of opening like a management API on the agent, which would allow you to build like a flex volume plugin or some similar integration that can poke the agent and say, hey, I'm turning this thing on, create a new socket over here. Here are the properties, to kind of work around what you're describing. It's not there today, but it's kind of on the table, and maybe we'll look at it soon, but you're certainly not the first to ask that question.
Cool. Any other questions?
Great talk, Tyler. So we talked a little bit about TTLs for workload certificates. Could you talk a little bit about what would happen if your zonal or regional CA that probably has a longer TTL is compromised, and how you might rotate that?
Good question. So when you're kind of like upstream CA or your SPIRE CA, so this speaks to a little bit to the strategy of what is your root of trust in SPIRE. There's a couple of different strategies. You can have SPIRE create its own key, self-sign it. You can also refer to another SPIRE server, in which is called nested SPIRE, to allow these things to sort of form a tree. But you could also just use a key pair that you provision yourself. And so what do you do if that thing is compromised? It's pretty difficult right now. I think we're planning to spend a lot of time on revocation coming up on the middle of next year, of 2020. There are some strategies. Right now, you essentially add the new key to your trust bundle and then rotate out the old one. But yeah, rotating a root key is much more difficult than rotating the workload keys that sort of have this thing, this rotation mechanism built in.
I didn't even think about this, but, and this might be a question for Evan too. What are the implications for federation and CRLs across trust domains?
That's a great question. All right.
So so first of all, the workload API does have support for delivering an X.509 CRL to a workload. SPIRE has not implemented X.509 CRL, but the workload API has support for it. The SPIFFE Federation APIs that we've currently defined don't really have any concept of revocation, like communicating revocation information across that wire. Right now, the implication of a compromise is usually, hey, I'm going to yank this root from the bundle. Since SPIRE propagates roots as well, we can yank a root from the bundle, we can propagate that change pretty rapidly and bring a new key in. I think that there's probably a similar story with federation, where you would expect the foreign trust domain, which is compromised, to nuke whatever keys out of their bundle were affected or chain down to the affected compromise. And that change would come across pretty quickly. But from a from a consumer point of view, I always have the option to sever that federation relationship if I think something screwy is going on your side as well. So I think there's a few options that we have. It's an area of active exploration, how to communicate revocation information across those boundaries.
Cool. I think that's about all the time we have. If you have any more questions, feel free come up and chat afterwards. Thank you guys so much, and enjoy the rest of KubeCon.